Hello everyone. My name is Noah Olson. I'm majoring in business and entrepreneurship, and my partner Matthew Dean, he's majoring in electromechanical engineering. And we are very excited to join this competition, and we are tasked with creating a reflected light to solar panel capturer.
We created this contraption here using an Arduino Uno to control this device and to log its data. We're utilizing a servo motor to position this device. We have photoresistors on top that detect either side, which side has the most light. And underneath here is our solar panel, which absorbs the reflected light and gives us a voltage reading.
And so our goals with this project were to basically capture reflected sunlight, and one of the reasons that we were tasked with this is solar panels always cannot capture direct sunlight. Sometimes light needs to be reflected, and we wanted to find the surfaces that best reflected sunlight into our solar panels, which usually correlates with objects with high albedo type. And also we wanted to have our prototype move in correlation with the sun, because the sun obviously doesn't always stay in one place. And we also wanted to be able to analyze our data and log it through Arduino, and most importantly, we just wanted to learn and have fun.
Okay, and our code, we utilized Arduino. In the beginning here, we are measuring the values of the photoresistors, and then it's going through and averaging and deciding which direction the motor should turn, and at the end it is logging the value of the solar panel, and we have that outputting to PuTTY, and we're logging that file. We utilize CAD to help us design our device. We were able to find an existing 3D model of the servo motor we're using, and that assisted in us making our mount. This is the mount that I had designed for our device, and we were able to 3D print that.
Yeah, so here it details the auto positioning of our prototype. You can see that as we move the light closer to one side or the other, that it will flip towards the emitted light source, which shows that for example, if the sun were to move throughout the day, that our solar panel would move towards the sun and be able to capture more light. Here shows our control variable. It rotated around 3.15. Next, we looked at the paper, which has a high albedo content because it's very white, and it was showing around a 3.7. Next is our aluminum foil, which is very reflective and shiny, and was almost our highest. It showed around a 3.9. And then we measured a plastic bag, which is very clear, and that was showing around a 3.6. Then we measured our Call of Duty Black Ops, which was showing around a 3.4, very dark, but not completely black. And then here's our black steel plate, very low albedo content, very, very dark. Very, very dark indeed. And then our data comparison, you can see that aluminum, which is very reflective, had the highest albedo content, whereas the print plate, which is very dark, very low albedo content, we would not want to use that type of surface for reflection. And then our future plans are to basically add more photosensors to increase our sensitivity so that we can control more variables in our environment, such as if the sun is rotating differently or if our solar panels are out of position. We also want to reformat the wiring to make it much more clean and usable in the real world. We want to be able to analyze our data better by plotting it. And lastly, we want to implement this data into a real-time app for real and practical use. So yeah, thank you.